అందరికీ నమస్కారములు. Today is the last day of our classes on Vedic mathematics by Gautham ji. If you have any questions, please get clarified. I'm going to unmute all of you throughout the class. Next, I have already announced, next Friday will be a practice test on Vedic mathematics. And also there is another test on 30th of this month. Then the final exam will be on 2nd of December. So with this, let us start the session with Vande Mataram and Prarthana. Let us request Challa Chitprabhu Garu to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujalam Supalam, Malaya Jasitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajyosna pulakitayamini pullakusumita drumadala shobhini suhasini sumadhura bhashini sukhadam varadam mataram Vande Mataram, Vande Mataram.
Vande Mataram. ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Now let us request Arun Kumar ji to chant Prarthana, please.
Sarvebhya Namo Namaha. Let us do 1 minute meditation. So, Om. Tvam Ganapatidum Havamahe Kavim Kavinamupamashravastamam Yeshtarajam Brahmanam Brahmanaspata Anashranvannoti Bhisida Sadhanam Om Shri Mahaganadhipataye Namaha Om Prano Devi Saraswati Vajebhirvajinivati Dhinamavitriyavatu Om Shri Mahasarasvaityai Namaha Gurureva Gatihi Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Na Guroh Paramam Shishurasmi Guroho Matirasti Gurau Mam Pahi Guro Jnananandamayam Devam Nirmalasphtikakritim Adharam Sarva Vidyanam Hayagrivam Upasmahe श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पाद शङ्करं लोकशङ्करम् शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ शान्ति शान्ति शान्तिः मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः श्री गुरुभ्यो नमः हरि ओम
ధన్యవాదములండి అరుణ్ కుమార్ గారు. Okay, now I request Gautham ji to start the webinar, please.
And sharing to be enabled. Namaskar. Today we shall cover the what is named as negative method. Yesterday I told that yesterday we discussed that actually it is coming from the other side of the binomial. The other consideration of binomial expression is binomial expression of 1 by 10n plus 1. It is basically coming from binomial expansion of 1 plus x to the power minus 1. Earlier we had everything is positive. If you see, earlier we had everything as positive here. It was 1 minus x to the power minus 1, all were positive, and as a result, 1 by 10n minus 1, which is say 1 by 19, 29, 39, and so on, everything was positive in that. Always we are doing 10r plus q, means 10 times the remainder plus q, the quotient. Now, what we'll do, we have seen that why it is required. I repeat that point, that when our denominator is ending in 1, up to denominator ending in 7 we can manage, but up to when the denominator is ending in 1, the fractions like 1 by 21, 1 by 31, 1 by 41, etc., we have to multiply both the numerator and denominator by 9, and it becomes it gives a very big number. For example, 1 by 21 becomes 9 by 189. 189, it becomes a very big number, and digit divisor itself becomes 19, which is the ekadikara purveno, the purveno of this 9, purveno of 9. So 18 plus 1 is 19. So we have to divide everything by 19, keep on dividing by 19 every step, like what we did earlier for, like in case of 19, we divided by 2. So in case of 29, we divided by 3. It is divided by, to be divided by 19, which is a very big number. So it is not possible. So it is better to use another kind of formula, another kind of algebra, and that is for 1/21, etc., we consider that these are the coming under the thing of under the category of 1 plus x to the power minus 1, because they are 10n plus 1. 10 times some number, say 21, 2 into 10 plus 1, 3 into 10 plus 1, so 10 times some number, 10n, we have done it, 10n plus 1. So if we expand that, it by finally becomes like this. So where you find that every step it is minus actually. So what we do, the procedure, I have done it here, but I will discuss it slightly later. Because it is coming, some another issue is coming, will be coming, and therefore it is avoided. Vedic mathematics book, these are handled by some 9 complement method, which I do not find much algebraically very clear, or it is something like very complicated. Here the algebra is simple, but here it gives some apparent complication because of the handling of the negative number. So I will first I'll go to a simpler example, and where this negative number doesn't come. It is like this. You start, say, want to calculate 14 by 41. 14 by 41. Here, digit divisor will not be one less than this. It will be just the same. Actually, it is actually, in both cases, we could have told it. It is the nearest power of 10. Sorry, nearest multiplication of 10. In case of 19 and 21, both, it is 2. In case of 21 and 31, 29 and 31, it is 3. I repeat, if in case of 19 and 21, which is around 20, it is 2. And in case of 29 and 31, which is plus minus of 30, it is 3. Similarly, it is for 39 and 41, which is near about 40. This multiplication multiplier of 10 is 40. It is a near about that number is 41. 41 also. 39 and 41 both are near about 40. So what we do, we simply do instead of 40, we write 4. As I told that the division of 10 is already taken care of when you throw it into the next decimal point. Now we'll work with 4, digit divisor is 4, and we start with 14. 14 divided by 4, what we get? 3 becomes my quotient and 2 becomes my remainder. So in case of 14 by 39, we would have worked with 23 itself. We make it 23. But here we imagine that there is a vinculum here, like above 3, as if. So 2 and vinculum 3 becomes 17. Although in the result we will not write a vinculum, but while calculating the next operand on which we will apply the divisor, we'll consider it to be vinculum. So 2 vinculum 3. So 20 minus 3 becomes 17. And 17, when you divide by 4, it is 4 is my quotient and 1 is remainder. Again, we will not work with 14. Instead of that, 10 minus 4, that means as if there is a vinculum above 4, as if there is a vinculum above 4. So we'll make it 6. 1 vinculum 4 is 6. And this 6 will work with 4, divide by 4. So it becomes 1 quotient and 2 remainder. Again, it is not 21. Earlier, what we did earlier, because everything is negative, you see that here, this expression, everything is negative. We have to do always, it is be negative that way. Vinculum, we have to imagine. So what we do? So 2 and 1, instead of 21, it becomes 19. 2 and 1 vinculum, so 19. Then, when 19 is divided by 4, again 4 is my quotient and 3 is my remainder. And now what will happen? 30 instead of 34, it will be 3 and vinculum 4 becomes 26. And 26 divided by 4, it is actually 6 quotient and 2 remainder. And it comes back actually to instead of 26, it becomes 20 minus 6 or 2 and vinculum 6, which is 14. We come back to 14 so that it will repeat. So it is these 3 is not happening. So these 3, 4, although you worked as if these are vinculum while working for the next opponent, next level, but here it is, we will be collecting that as it is, not the vinculums ones, and then it becomes 0.34146. Is it clear? First, let it be clear. Then I will go to 1/21 case where the negative, some negative numbers real will come.
Sir, Mahoday, 14 divided by 4, 3 is 3 and 2 coming. Badal mein 17, how is it come? Please explain that.
That's what I'm telling. You do
20 minus 3.
You imagine that as if there is a vinculum here, because in your expression there is a negative. Although in the final expression we will not use this vinculum, but here you imagine there is a vinculum, so it becomes 2 and vinculum 3 becomes 17. Okay, so like we operated with 14, next operation will be on 17 divided by 4. Again 4 quotient and 1 remainder, but immediately next to it we imagine that there is a vinculum here, so it becomes 1 and vinculum 4 becomes 6, because there is a negative in the expression. The expansion of 1 plus x to the power minus 1 contains everywhere it is negative. So that negative has to be incorporated in the quotient. We'll make the quotient negative, and then this will operate. This will work.
Why we take 20 minus 3?
2 and
20.
vinculum 3. 2 is vinculum 3 and what? It is 17. No?
Okay.
So
Okay.
similarly, 1 and vinculum 4 is 6. 2 and vinculum 1 becomes 19. 3 and vinculum 4 becomes. Now it is clear?
06 कैसे आई?
Yes.
10 minus 4. 1 and vinculum 4. What is what? 1 vinculum 4 is 6, no?
06.
6 or 06, same thing. You could have written 6 also.
17 मगर nearest 20 से कम करना है तो 4 कम करना है तो 16 होना
20 से 3 कम करना है, 10 से 4 कम करना है,
okay
20 से 1 कम करना है, like this.
Okay.
Now finally when it comes out, comes back and you comes back to 14. So now you remove all the vinculums and result becomes 3, 4, 1, 4, 6. 0.34146. Finally, you have to remove those vinculums. Vinculum you need not write. Vinculum you just imagine for the calculation of this one, next one. For the calculation of this one from this one, or this one from this one, you just imagine there is a vinculum here. Okay. So that is the procedure. Now I'll come to a complicated case, which is actually 1/21. Skip that. The method of 1/20. After discussing this one, where these are negative. Okay. So we consider that how to do 1/21. For denominator of the form A1, we simply divided by A. Divided by A, not by A plus 1 or A minus 1 anything, in a special way. Let us take the case of 1/21. Here digit divisor DD is 2. In case of 21, that as in case of 41 I did 4, so 2. We proceed as follows. 1 divided by 2 is quotient is 0 and 1 is remainder. It earlier also it happened. consider the binomial expression, we have to do 10R minus Q this time, instead of 10R plus Q, in case of 1 by 19, what we did earlier. Now 10 into 1 minus 0 is 10. So 10 minus 2 is, here you do not, because it is 0, you do not see any difference. 10 minus 10 divided by 2 is 0.5. Earlier also we got it like that. Then we became, we divided with 5, you remember? Divided 5, we got it 2, and again quotient 1, quotient 2 and remainder 1, then we go to 6, 3, and so on. But here not. Here Q is equal to 5 and R is equal to 0. So next is 0 into 10 minus 5. So this minus 5 or vinculum 5 it comes. Now, when we divide, this is the thing to be understood. This is also, at first I used Excel programming. There actually also there are a lot of problem came, and later I'll find that that I can discuss that instead of, there are two functions. One is round, and another was the three functions: round, trunc, and int. I found that int is working properly here, int. So there actually this works properly, and finally, that is a separate question. But you remember now that minus 5 when divided by 2, what will be quotient and remainder? Here, this is I have written. Quotient can be negative, but remainder is never negative. This you remember, and Q becomes minus 3 and R becomes 1. You please understand this one first. Minus 5 when divided by 2, quotient is minus 3. On a number line, if we put say 0 here and all the positive numbers 1, 2, 3, and so on, and minus 1, minus 2 here, minus 1, minus 2, minus 3. So minus 5, 4, and 5, minus 5, minus 6. So basically, as if first you have to divide it by minus 5, minus 6 instead of minus 5. So when you divide minus 6, it becomes minus 3. Quotient becomes minus 3. But there is it is not minus 6, but minus 5. So there will be positive thing, something, this will again go towards this side. So that remainder becomes 1. Remainder becomes 1. Quotient is minus 3 and remainder is 1. Because minus 3 into 2 plus 1 is minus 5. Here I put the star. Star means quotient can be negative, but not the remainder. Then so far we have in a real line shows 0, 5, and this minus 3, vinculum 3. Next, 10 into 1 minus 3 becomes actually, this becomes reverse again. It actually works on vinculum again. Vinculum of vinculum becomes again positive. So it is 13. 13 divided by 2 is, quotient is 6, remainder is 1. So we write 0.053 vinculum and 6. Next is 10 minus 6 is 4. This 6, 10 minus 6 is 4. So 4 divided by 2 is, quotient is 2 and remainder is 0. So it is 0.5362. Next, 10 into 2 minus 2 is minus 2. Again, minus 2 is, quotient is minus 1 and remainder is 0. The result will be 0.5362 and then above 2. Then a dividend again is 0 into 10 minus 1 is 1. It comes back to 1. So it is actually 1 by 21 becomes 0.05 vinculum 3, 6 to vinculum 1. So if we clear the vinculum, it becomes 0.047619. You can match with calculator. But had we done with 189, it will be very lengthy. So I have shown properly here, see, here. Very complicated. So 1 by 21 basically is, 1 by 21 is how much? It is 9 by 189. 9 by 189. It is positive method, our earlier method. So 9 divided is 19. So 9 by 19. 0 is quotient and 9 becomes my remainder, 90. So again, 4 19 is 76. 76 plus 14 is 90. So 4 becomes my quotient and 14 remainder. And 14, 144. Again, you do 19 into 7 is 133. This 144 minus 133 is 11. So 7 quotient and 11 remainder. So again 117. Again, because very big numbers, always you have to multiply by 19. Very complicated. Instead of that, you just with that, you just break your operation with negative numbers. Like I told that vinculum, it is a negative face value. So you use as easily, but with practice, you can use this negative face value as easily as you are using since childhood the positive face values. So so there should not be any problem here. 1 divided by 2, but with that 0 and 0. Pardon me? Here you are getting directly 47. Here are getting, only difference is that you are getting 5 and minus 3, and you have to clear it. That is the only thing that remains. Is it clear? Should I repeat?
Gautham
It
ji,
is clear, sir.
I have a question.
Huh.
See, 189 with by 90. I mean 1 by 21 has been converted into 9 by 189.
Exactly.
And 19 is and you did whatever it is. So eventually the answer should be the same on whether you do by 1 by 121.
Yeah. It is the same. It is the same.
But the numbers look different. So
Why?
90, etc.
No. 5 and vinculum 3 is the same as 47.
Okay.
2 and vinculum 1 is 19. Others are same. 3,
Right.
0, 0, 6,
Okay.
6. Huh?
Right. Thank you.
Okay. So is it clear?
Yes, sir.
So I have written here in the below. 5 minus 3 is 47 and 2 vinculum 1 is 19. So that is the thing, and to avoid that, I first discussed about 14 by 41, where I found that there is no vinculum case. Now, this is very interesting. I'll tell you. See here. See, 14 by 40 is how much? .35, isn't it? But you consider that way, I'll tell you. 14 by 39 is how much? .35 14 divided by 4. This 3 quotient 2 remainder, 23. 23 becomes 5 quotient and 5 quotient 3 remainder, 35. 35 divided by 4 is 35 divided by 4 is 8 quotient, isn't it? 2, 3 remainder. 3 quotient 2 remainder, 23 becomes 5 quotient 3 remainder, 35. 8 quotient 3 remainder. 8 quotient 3 remainder. 38 is
9 and 2.
9 quotient 2 remainder. 359, 3589, something like that. And 40, whereas 14 by 41 obviously will be is equal to that 0.34146. So here this one 5 8 and so on is 5 and 3 4 1. So you see that, just imagine that 14, had we done 14 by 40, it just end in 0.35. But because of that, those expressions in the binomial expansion, we had something positive. Or in case of 39, we had something positive all the time. And because of that positive one, it is not satisfied with 0.35 alone. Again, there is something more coming from the next level, next term actually, next term, it becomes 8. Again, something next term, always adding, something like that. Whereas here, it became less. So when you did it, instead of 23, we do it 17. So obviously it will be, we got 4. Instead of 5, we got 4 here. So always it will be less, but not that less. Next will be that slightly more than what we expect. So again it becomes 4, not exactly 0.34, but something more. Again something less, something more. It alternates to this because of these terms, alternative terms, or square, cube, and so on. So this is just to have a mental this thing, that how around, basically we are working with 40. When we are dividing by 4 and throwing it to the next decimal point, we are basically dividing by 40. But had we divided 14 by 40 only, we would have stopped at 0.035. Instead of that, we every term, all the term by term, we are using by dividing by 40, but in a special way and going to turn by turn. That is the idea of this binomial expansion. Always we are not stopping, but it is going on turn by turn. This negative again, this something always. And here, this is the thing. This is the 14 by 40 would have stopped here. What is that? 0.35 here. And here it is coming, it's of 0.35, it is reducing it and make a 4, again something 1, and so on, coming from all these steps. That's what I'm saying. Imagine that always whenever we are doing this thing, it is not a mechanical one. It is always you are when you are doing this quotient and remainder things, always remember in the background, you can those of you who are inclined to that. Procedure wise is okay. Procedure wise you can do it like that. But anybody, suppose somebody, why I'm doing this? You can think. So that way you can think that every step we are using turn by turn, the binomial expansion is coming. But in the conventional mathematics, it's very difficult actually. If we do it, we always have to be in the conventional method. We have to be always really dividing by your conventional method, and always you then adding, and it will be very complicated. You cannot manage it. But here you can do it very easily. I'll give you this thing. I will share another thing. What is that? Open. Oh no, it is not. Sorry, it is taking little time, but yeah. So this is this how I calculated all this and came to this one. Can you see it? The screen?
Yes, sir. Yes.
Yes, sir.
I will show you from the beginning. Actually, a lot of other things are coming actually on the screen. We cannot stop it. See, beginning I'm showing you. This is the positive method. See, positive I have written. One-line method for calculation of fractions on any length of recurrence. So 1 by 19, that you have the 0.05662 and so on. It came like that. How we did it? Those of you know Excel, see 19, I put 19 and 1. This numerator denominator I put. Digit divisor is this round of these things. This round function gives both for 21 and 19. Both for 21 and 19 it will give 2. Whether I use positive or negative. Now this one, it is the integer part of. I'm sorry to some persons who do not know Excel, but for those who know Excel, you will enjoy it like this thing very much. And integral part of, this is the int that I told, that not trunk or around, int of 10 times of that q. There is nothing like that. 10 times of q will be coming, plus, 10 times of r plus q, and divided by the digit divisor again. The digit divisor is in C7. C7 is here. So it is digit divisor. So it will get, and this one is below is the remainder, 10 times of that this thing and modulus of that. Earlier, you have to do 10 times of the this thing. 10 times of r plus q will be there by next operand, and we will be modulus of that. It is the integer division of that and modulus of that. So that way, and then you just select it and you just drag, and it will generate all the up to that. It will finally it will repeat somewhere. So we'll find that I've done for 1988 by 19, and then p means prime. These are prime, so there is a particular behavior. It is full length is full. 19 it becomes 28 is the length. So 19 is actually 39 is not prime, it is 3 into 13. So this length is only 6 here. So 49 again, 7 into 7. It becomes something by 49 becomes a 42 length. See, very big, 42 length. But whereas this, when I do 7 by 49, becomes only 6 length. 59, it becomes 58 length. Again, 69 is 3 by 23, it becomes 22 length. The 22 into 366, and the other two are the 1/3 of the factors of that, 23 by 69 and 46 by 59, 69. Those are 1/3 and 2/3. So that way 79 has 13. Somehow there is some reason why it comes. It is not 78 length, but it's 13 length. And there will be obviously more cycle like this. These six cycles, 6 cycle of 13 length each. And 89 has 44 length. So like this one, it goes actually. 119, it becomes, I'll go towards left, it is actually why I put the dot, the other one can be done with 9's complement. Actually, it is of 108 length. Total is 108. 108 is the length in case of 1 by 109. So that way I did for a lot of them. And similarly, negative method also I started with, these are very alternate actually, 1 by 11. How it comes actually 1 minus 1, 1 minus 1. And actually it's 0.090909 in case of 1 by 19. 1 by 11. Now here it comes that 9 by 89. Basically, sometimes I did screenshot from this one and use this in the presentation. So it is also here the formula. Formula is here he did, the first one is 10 times this thing plus this thing and this thing, and this first time is this, but second time onwards, here, it is the positive answer, sorry, this is the negative one. See, first time this was that, whether you do positive or negative doesn't matter, because nothing is here. The next one, see, here you put minus 10 times of the remainder minus quotient divided by this digit divisor. So similarly, this one, if we drag it, it automatically comes with some vinculums. So that way, 31 is like this, 0, initially it will not come, then again it will come here. I've chosen that 14 by 41 from here. By other 1 by 41 gives a vinculum. Suppose I have to discuss without any vinculum. See, 4 by 41 also doesn't have any vinculum. 14 by 41 we discuss. Suppose I make it 14. This one has vinculum. Suppose I make it 14. We will find that. That is, we already discussed it, 0.34146. There is no vinculum involved here. So I have chosen that discussion. Similarly, these are all there. 1 by 17 you can do by 3 by 51. It will come like that. So like this is my Excel sheet for this one. And I come back to that one, stop share. Is it okay? You understood the thing? The idea behind this? These are the screenshot from the Excel sheet. Any problem in our understanding? Then I can go to the next one, divisibility. 7:30. Okay, there is enough time. So, what was the problem in our understanding about this one? Any reaction? Should I proceed?
The question is to students. Please tell whether you have understood or not.
నెమ్మదిగా మొదటి నుంచి అన్ని చదవాలండి, అప్పుడు కొంచెం బుర్రలాగలుగుతాం. ఒక గంటలో వెళ్ళేది కాదు ఇది.
Not clearly, sir. Understood a little bit, not fully.
This which actually, so for the simpler one or the complicated one? This he understood how it came. What is the procedure as compared to 14 by 39? See, suppose you do 14 by 39. What you did? 14 by 39. We repeat that thing. Yesterday's thing. 14 by 39. What you do? For calculating 14 by 39, we do dividing 14 by what?
4.
14 by 4. I give it different notation. This doesn't mean exactly division, but it actually is 14 by 39. 14 by 39 equal to 0.3 becomes my quotient and 2 becomes remainder. It is 23. Okay. Now 23 divided by 4 is how much? 5 quotient, no?
Yes, sir.
5 quotient
3
and 3 remainder. And then 35. Then
8 8 3
8 3.
6
Then 38
38 6 9 2
9 2.
2
And then
29 7 1
7, 7, 1.
Mhm.
Then
4-1.
4, 1. So when we get 4, 1, that means 14. Again, it will be, again divide, so it will be 3, 2, and so on, again 5, and so on. So we put a dot and dot here. So you have to 0.358974. Oh, sorry, not here. Here. So 0.358974. Is it okay? Here, up to here is okay, same. This 3 remainder and 3 quotient and 2 remainder. But earlier we did what? 23. But you remember that we are dividing by 41. It will be less. So dividing by 40 is end in 0.35. Dividing in by 39, which is less than 40, it will be slightly more. So 35, it goes beyond, or term by term, 358974 it becomes. But here it will be less than, obviously it will be less than 5. So this 23, instead of 20 plus 3, you do 20 minus 3, as there is a vinculum. So now it becomes 17. So 17 divided by 4 is how much? 17 divided by 4 is 4 quotient 1 remainder. Sorry, 17 quotient, 4 quotient and 1 remainder. 17 by 4. So again, instead of 14, we consider it to be as if there is a vinculum. And it becomes 6. It converted into 6. Now you work with 6 only, not 14. So it becomes 1 quotient and 2 remainder. It becomes, instead of 21, we write as if there is a vinculum and write as 19. Then this 19 we divide by 4, so it becomes 4 quotient and 3 remainder. So again, instead of 34, we consider to be as if it is like this. So it is 26. And 26 when divided by 4 becomes 6 quotient and 2 remainder. And again, instead of 26, it becomes, earlier we always don't have to write by brackets separately. You could know that is 35, it is 38, 29, so on. Here it is 20, instead of 26, we consider it to be 2 and 6 vinculum, so it is 14. So it comes back to 14, and either it ends, so it is like this. 1, 3, 4, 1, 4, 6. Then you remove the vinculums. Vinculums, you just imagine that for calculating this one, you don't have to write vinculum. Otherwise, it will be taking confusion, because somewhere actually vinculum has to be written really, because in the other case of 21. Now it is okay. Now when you come to this one again, 21, how it happened? I removed. How it happened? 1 divided by 2, 0 and earlier also we got it in case of 19, no? Instead of 1 by 19 also we got like that. 0 and 1. 0 quotient and 1 remainder. So it comes to then now becomes 10. Now 10 divided by 2 becomes 0 quotient. 10 divided by 2 5 quotient and 0 remainder. Yeah. Now 5 quotient and 0 remainder. Earlier we did work with 5. Now we'll do it minus 5. This one, because 0 remainder is not giving anything, but it becoming negative. Even 1 quotient could have made it positive, but when 0 quotient comes, no, sorry. Even one remainder would have made it otherwise. So even whenever zero remainder comes, the problem comes there. So it will make it zero remainder comes, so it will become -5. This -5 when divided by 2. So first you have to we normally do the 5 divided by 2 is 2 quotient and 2 quotient and 1 remainder. But when -5 divided by 2, it becomes -3 quotient and 1 remainder. That is the thing you have to understand. It is not -2, but it is not -2 quotient and -1 remainder. No. Remainder is always positive. Remainder is always positive, always positive. So -3 is my quotient and 1 is remainder. So -3 is quotient, 1 remainder. So you write this 3 becomes vinculum. So likewise we proceed. But again here you have to consider. We got it 3, -3. So as if we got like this, -3 and 1. So instead of here 7, in the bracket we have written that is 13. Suppose we remove money, suppose it had been like this. We write in this form. -3, when vinculum 3 is quotient and 1 remainder. But we do not work with 1 and 1 vinculum 3. But we remove make it vinculum again. When we remove the vinculum, so it becomes 13, not 7. This also you have to understand. It is minus of minus. So it becomes positive again. So 13, and then quotient becomes 6 and 1 by 1 remainder. So this 6, it goes like that. You just practice it. You see this slide and then you can practice how it is happening. It is happening directly. Excel doesn't consider it. Excel, I just drag it and then everything comes as it is supposed to be with the formula, correct formula. So I think it is, now I come to.
Sir, excuse me, sir.
Yeah.
Let's go to previous screen, sir. One more screen. This -5 has come here now.
No, -3 has come.
No, not sir. Another one, sir. That now just now we discussed.
Yes. -5.
Generally, sir, in all conventional method, if 0 comes, there ends the division.
No, 0 didn't come, no.
Otherwise, in normal way, if remainder is 0, then there ends the problem.
No. It is not that procedure. It is term by term evaluating. I'm not. Remainder is 0 is not coming with 21. Remainder is coming with 2 here. It is procedure different.
So in normal method,
Earlier she got remainder 0.
There ends the problem.
No. You are little bit. You are thinking in different way. So earlier also we got remainder 0 comes when divided by 2. Remainder will either be 1 or it will be 0. And turn by turn we have to do it. Again you have to put that with the quotient. If the remainder is 0, you have to work with quotient, only quotient. But here it is changing the sign. That is the only difference. Earlier, in case of 19, we worked with 5. Here we will work with -5. That is the only difference. So you remember that earlier we worked with 5.
I am comparing. Suppose in normal conventional method, if we are dividing
no, it is not 2. That method. It is not dividing at all by 19 or 21. It is dividing by 2. It is dividing by digit divisor. It don't mind it. It is turn by turn evaluating. So therefore, it will be coming 0, 1, 0, 1. Many times it will come. And in case of higher things like in 4, it will be coming 0, 1, 2, 3, all various 0. This is not the question. Now I come to the point. Pratula Ravindra Kumar, can you remove this?
No, he only talked just now.
Oh, acha, he only talked that. Acha, this screen is, this writing is there on this. Acha. Can you remove your hands? Yeah, thank you. Acha, Vedic online method with n by a7. Now here we did with n by a1, ending with 1. Here you do, again I repeat, with a7. Denominators ending in 7 can be have two ways, because 7 is also quite high. You have to multiply by higher number. By 7 actually you have to multiply again. So denominator ending in 9. To make it, make this denominator ending in 9, you have to multiply both numerator and denominator by 7. Or is also quite high. Earlier we avoided dividing by 1. So 21 has to be divided by 1. Dividing by 9. 21 has to be divided by 9. Here you have to divide by 7. So 8 by 17 can be as high as 56 by 119. So therefore digit divisor will be 12. 12 also is quite high. So instead of that, we divide, what we do? We multiply by 3. Instead of multiply by 7, multiply by 3, so that it ends in 1, and we come to negative method. When you are confident about negative method, you can better use negative method. Here you count 8 by 17, for example. 8 by 17, it came to 0.47058882 and so on. Sorry. And it is 24 by 51. In negative method, it comes 47062. It is actually 58. And 3 and 3, 1, 3 minus 1, the 3 being equal to 1 becomes 29. So that way you can choose between, you can do any of them. So denominator 7, ending in 7, you can handle this way. Now there has been some exercise. Kindly go to this slide and you can do this exercise. Okay. Exercise on recurring decimals.
Sir, once show in previous slide.
Both I am doing the same thing, same result. But one is direct and another is with vinculum. But it is actually, in my opinion, this simpler. But for 7, one can choose. One can.
Sir, one question. 56 by 119. How can we divide 12? It will be 11 only.
No, 56 by 119. I am dividing that one more than this plus 1. This plus 1 is equal to 12. So 12 is my digit divisor, DD. This is DD actually, DD.
Okay.
So 56 divided by 12, it is 4 quotient and 8 remainder. Okay. 84, 7 quotient, 0 remainder. And 07, 0 quotient, 7 remainder. 70, 5 quotient, 10 remainder. 12 plus 60 plus 10 is 70. So that way it goes actually. Okay.
Okay. Thank you.
Now these are the exercises as I told. Now I come to periodicity of recurring decimal. Now periodicity of recurring decimal, how it comes? It actually, there is something called repeat 9. Repeat 9 is 9, 99, repeat of 9, 999, 4 number of 9, 5 number, and so on. So these denominator 3 has periodicity 1 because 3 is a factor of 9. Denominator 11 has periodicity 2. This 1 by 11 is 0.090909. So because it is actually, it is a factor of 99. Denominators 27 and 37, these are the periodicity 3 because they are factors of 999. We have seen that in case of 41, the periodicity is 5. 0.34146, 0.34146. How it coming? It is because it is factor of 999, 5 numbers of 9, 99999. 7, 13, 21, these things all are periodicity 6 because they are factors of 1 by 7. 7 I have seen a 0.142857 because this is a factor of 6 numbers of 9. So I've tabulated these things, how it comes. There is actually, the notations are there. The hollow, there's something called hollow. You can ignore it for the time being. These are the, instead of writing all the 9s, I put 10 to the power something minus 1. So these all numbers are, see, 41 came here with periodicity 5. Here the 7, 13, 21, all these things came with periodicity 6. Periodicity 1 is only 3 and 9 actually. 3 and 9 also, 9 itself. 11, 13, 11 or 33, something by 33. These all will coming periodicity 2. Periodicity 3 will be 37, 27, and there is some more. And 4 periodicity will come only for 101. 5 periodicity come for 41, 271, 123. 123 actually 3 times of that. 3 times of this will always come. 37, even 111. 37 into 3 is 111. So that will also have periodicity 3. So that some multiplication. 73 and 137 periodicity 8. These are periodicity 9 and so on. 19, see, 19, we have, 19, see, 19 has periodicity 18. We have no 9 because 19 is a factor of 18 numbers of 9. So 10 to the power 18 minus 1 is 18 numbers of 9. So 19 is a factor of that. So it has length 19. 18. Now, okay, that is with a little so remaining time we start this. I think it will be ending also. If required, we will be doing another class that Cornelius have told. Now, divisibility. Okay, now clear all these things and concentrate on the divisibility. Now, numbers 2 and 5 being factor of 10, we have similar rules for both of them. Divisibility by 2 to the power n, any power of 2 requires the same number of n digits. When that power amount of some 2 to the power n, so n digits should be divisible by 2. You know, divisible by 2 are, the last one is divisible by 2. What are these? Last one is anything ending in 0, 2, 4, 6, 8. This even number, we call them even number. Even number is divisible by 2 and they're ending in this. Not the not 1, 3, 5, 7, and 9. Similarly, for 4, we have to see the last 2 digits. Like 48 will be divisible, but not 46. Always 46 is divisible by 46 divisible by 2, but not 4, because for anything ending in 46 is not divisible by 4. So, but 56 is divisible by 4. Something ending in 56. Similarly, in case of 5, so either this 0 or 5, ending in 0, we know all this trivial thing. 0 and 5 has to be divisible by 5. But in case of divisible by 25, there have to be divisible by, it has to end in either 25 or 50. This should end in 50 or 75 or 00. Something divisible by 00. So 200 is also divisible by 25 because this is divisible by 25. Divisibility by composite numbers demands divisibility of its factors. Like 42 is divisible by 6 because it is divisible by 2 and 3 as well. So 135 is divisible by 15 because it is divisible by 3 and 5 both. And divisible by numbers ending with 2, 3, 7, 9 has general method called osculation. And this, in case of 3, 9, and 1, because oscillator is 1 plus 1 or minus 1, we'll see later. So these are actually taught in schools. Divisible by 3. A number is divisible by 3 because sum of its digits is divisible by 3. Like this one is all this. If we add all these numbers, it becomes 24, and which is divisible by 3. So because it is divisible by 3. But it is not divisible by 9 because 24 is not divisible by 9. Whereas a number is divisible by 9 if sum of its digits is divisible by 9. For example, this number is divisible by 9 because if you add all these digits, it will be 27 is divisible by 9. And since it is also divisible by 3, it is divisible by 3 because 9 is 3 is a factor of 9, so anything divisible by 9 also will be divisible by 3. Now, divisibility by 11. A number is divisible by 11 if the difference of sums on alternative digits, say even and odd positions numbers, is either 0 or divisible by 11. For example, the number 934571, if you add this alternative 934571, 947 alternate 7 and 351. So these we add one clay, this also we add, and this is divisible by 3. It could have been 0 also. Had there been 0 also, like say 1111. Simplest. So this is divisible by 11 because this plus this 1 also, this is also 1, and difference is 0. So the difference can be 0 as well as difference can be divisible by 11, then it will be divisible by 11. So this exercise has been given. You can note down this thing. You can note down from this slide also later. It is divisible by 3. It did test it. Now, osculation method. A 2 or more digit integer n can be expressed in the form. Those of you interested in algebra can do it. I will not discuss right away because there is not much time. So there is a osculation algebra is there. There's a lot of proof is there, and so actually I'll directly go to the procedure. For the time being, if time permits, I will do. So I now have to see. This is very. The irony is there. I've seen good textbooks. Even Russian book was there. Discussed about many fundamental things, but they skip the divisibility by 7. You remember all we did composite number. We did 2 and 5, and then we did 9, 11, 3. But we skipped 7 very carefully. We thought that is very complicated, but it's not. According to Vedic mathematics, divisibility by 7, 13, 17 are not complicated at all. These are only you have to see that it is a method called osculation. So osculator for 7 is actually -2 or it is 5. So tell you what is that osculation means. First, we find the osculator of 7. We find that actually this is the way to find the osculator of 7. We find that 10 into 5 is 1, or we can get it 7 into 7 if you do. Anything ending in 7, you have to multiply by 7 so that it ends in 9 again, that particular thing, 9, or ends in 1 also. This becomes 1, or 7 into 3 is 21. So it is actually 20 plus 1, so we have to work with -2, or it is 49 is 50 minus 1, so it will work with +5. So either -2 or +5 we have to work with. But what the work is that you, any given number, you cut it like this and multiply with 3. Multiply with 5. So this, it becomes 34 in plus 34 plus 3 into 5 becomes 49. The 49 is divisible by 7, so 343 is divisible by 7. That is the idea. A big number, take 64740. I want to check whether it is divisible by 7. I cut it first. Unit digit we separate. Now we do 647 the rest of the things, the rest of the digits plus 4 into 5. So it becomes 6492. It is 20, it is 20, so it is 92. Again, we cut like this. So 649 plus 2 into 5. So it is 659. Again, for 659 we do, or we cut this like this. 65 plus 9 into 5 is 110. It is 110. Again, you do 11 plus this. So 11 is not divisible by 7. So the whole thing, all these things are not divisible by 7. Okay. Test of divisibility by 13. So if you do 13 into 3, it ends in 9. So it's 39. And 39 is actually 40 minus 1. So this 4. 4 becomes my oscillator for 13. What do you do? I cut the number. This 11635 divisible by 13 or not. So cut the number here. So 1163 plus 5 into 4 is 1183. Again, I cut this number here. Now 118 plus 3 into 4, which is 130. And 30 is also, of course, 13 itself. You can see it. Either you may not do it. This is not required. This part is not required. By looking at 13 by 130, you find that this divisible by 13. So all the other 1183, all these things are numbers are divisible by 13 because these all are divisible by 13. Test of divisible by 23. We find that going to 23 into 3 actually is 69. Is 69, which is 70 minus 1. So 7 becomes my oscillator. Oscillator means with which we multiply the unit digit. So 4128, let's see, 4128, 5, 4128 plus 5 into 7. The oscillator is 7, so to multiply by 7. So 5 into 7, this becomes 4163. 416 plus 3 into 7. So this 437 and so on, it becomes 92. So 92 is, we know it is divisible by, you can work with this, or 92, we want know that is so much small. So 92, know that is 4 times of 23. 23 into 4 is 92. So it is divisible by 23. So at any moment, if you understand that it is divisible by that number, divisor, or not divisible, whatever it is, you can understand, they will solve the process. You can stop it in 92, or you can again do it and go to 23, doesn't matter. Now multiply numbers ending in multiplying number ending in 3 and 7 by 3 and 7 respectively, we get oscillator. We get the idea of oscillator. So 17 and 7 is, pardon me.
Sir, test divisibility 41285 by 23. How it is? How can we idea 7 is?
7 is the multiplier. How we are multiplying 7? But because we see that 23 into 3, we have to immediately something ending in 3. You have to multiply by 3. So you get a number ending in 9, and then you find that it is what the multiplier of 10 is just before one, more than that. So it becomes 70 minus 1. So 7 is my oscillator. Actually, there is a lot of algebra. I skip the algebra. Those of you who are interested in algebra, you can look at that. And if you do not get it, I'll discuss it. So this is that there is a test. There is a test divisible. There is a test number. It is the oscillator. This is the oscillator that what it did in case of 7 with 5 and so on. But for 7 it is 5. For 13 we use as 4. For 23 I use 7. This is this one. And unit digit here multiplying and adding with the rest of the number, it will be smaller than the number. Then whole number is 10. This one. It will be test number is will be smaller, and it repeats the process. So that is the thing. You understand these discussions. I skip that because of lack of time. But of course, first to understand the procedure. Should I repeat the procedure? In case of 7, it is 7 into 7 is 49, which is 50 minus 1. So 5 is my, because it is 50 minus 1, 49 is 50 minus 1, no? So 5 becomes my oscillator. So we do it with 5, 34 plus 3 into 5. 34 plus 3 into 5, 49. Okay. So that like that, like for 13 it is 4, for 20 it is 7. Now I come to again another concept called negative oscillator or minimum oscillator. So in case of R, this is we have to do R minus M algebra, but what you do? Yeah, we find that if we multiply 7 by 3, it is 21. It is also above or below a multiplier of 10. So it is 20 plus 1. So if it is plus, we have to consider it to be oscillator becomes negative. Earlier with negative, this you remember. If something is, say, 49 is below 50 minus 1, so oscillator will be 5. But this 21 is 20 plus 1, so oscillator will be minus 2 in case of 7. So earlier we did again discuss earlier. Either you do like this or we did like this. So its oscillator was 5 and oscillator is minus 2 again. So we can use minus 2. Okay. And here I have a comment that this comment was there that in case of, we always in textbook, childhood, we find that we understand divisibility about 3, 9 and 11 because their oscillator is only plus 1 and minus 1. And plus 1, always you are adding, so adding all the digits. Means what? You are adding, if you do step by step, adding the unit with rest of the, again adding with the unit with the rest of the thing, it is means to say adding all the total number. Similarly, 11, why we grouped alternative numbers? Because oscillator is minus 1. We always unit digits you are doing negative and we subtracting, again subtracting. So it amounts to alternative of my plus and minus. So this people didn't understood that this is actually coming from oscillator method, but it is plus 1 and minus 1. But in case of 7, 13, these are something other than 1, other than plus 1 minus 1, so they left it. It is very complicated, so do not do. This is why I feel it very sometimes why people skipped, where we are deprived of divisibility by 7 and so on. Now I testing divisibility by 7 using minus 2 as the oscillator. So it will be, you will find that 842912, I have to divide, I have to make it divisible by 7. So we test the divisibility. So what do you do? 842912 is actually 84291 minus 2 into 2. So it is this one, it becomes like this. Again, we subtract this thing. Here you cut to 2, here we cut to 7. Sorry, this 7, like this 7. So this thing minus 22 is this one. Again, you cut here. So 842 minus 42, 833. And again, we cut 83 minus 27. This 77 is divisible by 7. So therefore, all the back numbers, including the final, actually what we wanted, all these things are divisible by 7. Note that for divisor ending in 1 or 7, you multiply using oscillator, positive oscillator. This thing negative oscillator minus 2, but for positive oscillator 19 is negative oscillator for 19. For example, in case of 21, it is itself is minus 2, but for positive oscillator, but its positive oscillator is 19 because that again that multiplied by 9. And in case of 17, now you tell me what is the oscillator of 19? Anybody can tell? What is the oscillator of 19? Subtract divisibility 19.
2.
2. It is positive 2, plus 2. Because it is 20 minus 1. 20 minus 1. 2 plus 2. But it is for 21, it is minus 2. Okay. So, here is a table that oscillator is written here. So this is the positive oscillator 1, 2, 3, 4 for 9, 19, 29, respectively 39, 13, 4, 7, 5, and negative oscillators minus is minus 1, minus 2, this one, minus 1, minus 2, minus 3, minus of that is n is there, minus n, this minus n. So it is 11, 21, 31, 41, 51, and so on. And 51, obviously for 51, 17 comes. With 21, 7 comes. Okay, this can be ignored because it is already much lesser is there. If less is there, it can be multiplied. Something can be done with more also. It can be work, but actually. So you have just for completion of that thing I've written here. This table you can see that what is the oscillator and different numbers. Now this is about this thing positive. Now this exercise of divisibility. You just do this thing exercise. Now we come to a point. This little time is there, no? Yeah, this 10 almost 10 more minutes. Now I come to a point. Divisible by composite number. Composite number is I give an example. We have to divisible by say 92 or 93. What is that? I have to test whether this 8556 is divisible by 92. Express 92 in the form 23 into 4. The number 8556 is divisible by 4 because it ends in 56. 56 is divisible by 4. Now, oscillator of 23 is 7. Because 23 into 3 is 69 and 69 is 70 minus 1, so 7. So we do this thing, we can do like this, and into 6 plus 7 is this thing, and again do like this, 89 plus 7 into 7, 138, and the 2 is 13 into this, 13 plus 8 into 7, 69 itself becomes 69 and then divisible by 23. And here you need not do again. 6 plus 9 into 7, 9 into, again becomes, if you do 69, we play with 69, it will come back to 69, doesn't matter. So 69 is free, immediately you understand this divisible by 23, so you end there, this example. Now here, therefore, this is divisible by both 4 and 23 because, so this is divisible by 92 as well. Now whether I test whether this 8556 is divisible by 93. 93 is actually 3 into 31. The number 8556 is divisible by 3 because it is 8 plus 5 plus 6 is 24 and is divisible by 3. Oscillator of 31 in itself is near about the 30 minus 1. 30 plus 1. So it is oscillator is minus 3. So 8556, I do it like this. 855 minus 6 into 3. So 8, what is minus is equal to 83 minus, again 83 minus 7 into 3. 3 is my minus 3 is my oscillator, 62. And divisible by 6. We need not do it. Again, 62 becomes 6. And minus 2 into 3. 0. It can be 0 also. Either 0 or divisible by that number, it becomes. Here I put 0. If it becomes 0, then also it will consider as divisible. So it is divisible by 31. Or 60 or 62 itself. I give an example that you can do like that. Therefore, this 8556 is divisible by both 3 and 31. Therefore, it is divisible by 93. Okay? Clear? Now come to multiplex oscillator method. So I did similarly some algebra. This algebra I can discuss it only on request, or some people ask me, even after the class also some people ask me, I can do it. Multiplex oscillator. Here, actually, we work with single digits. but there may be coming cases where we have to use with multiple digits. So they are called multiplex oscillator. Here we actually group it unit digit, block of unit digits. For divisor of the form, divisors, mind it, not dividend. Divisor of the form 199, something divisibility by 199, 299. You may ask that why we require to switch it, but actually for there may be some requirements, and it will come. Factors of this thing may come. We would have taken oscillator as 20, 30, 40, like this, 20 into 10 minus 1. So it can be, oscillator can be 20. Oscillator can be 20. Earlier we did. But at the same time, it is 200 into 1 minus 1. The 199 equal to both. The 199 is equal to 20 into 10 minus 1 or equal to 200 into 1 minus 1. So it is called multiplier oscillator. So multiplier oscillator can be this 20. Simplest oscillator is 20, but multiplex oscillator can be 2. 20 to 10. So 200. Oh, no. I'm sorry. This I didn't do properly. 2 into 100. 2, not 200 into 1. 2 into 100. I didn't do properly. So 2 into 100. 2 becomes my oscillator, multiplex oscillator, and 20 my simplex oscillator. So instead of that, we also work with 2, 3, 4 multiplex oscillator. Now let us check whether 21961555 is divisible by 299. Now second order, when it is multiplied by 100, it is called second order. Second order oscillator is 3 because it is 299 is equal to 3 into 100. Multiplying by 100 make it second order because there are 2 numbers of zeros. That is important. How many numbers of zeros? Is 3, positive 3, because it is negative now. Negative is there. We proceed oscillator by writing dividend in group of 2 from right. So you see we have written group of 2. Now we again cut these 2 numbers. So 21961 plus 55 into 3 is this one. Again we cut this one. This is 221 plus 26, 22, 229. It came back to the same number, so it is divisible. This big number is divisible by 499. So what do? We cut into numbers. This is actually 5. So this you have 69, you have separated. This actually. Again we separate this last one, 87. So this one plus 87 into 5, this one. So this one again, so it is actually 499. This is 500, 5 into 100, 5 into 100 minus 1, 499. So second order oscillator is 5 plus 5 because this is minus. So this is this one, it goes like that. It finally goes to 49. It could have come to 0 also, and then it becomes 0 will not come in this positive oscillator, it comes negative oscillator. It comes to the comes back and it becomes divisible. So multiple oscillator 401. Now here we found that it is 4 into 100, 401, 4 into 100 plus 1. So second order oscillator, 2 zeros, second order oscillator is 4 minus 4 because this is plus. So this is second order oscillator is minus 4. Okay. Now this is, you got it here. So this minus 32 by 4 becomes like this. Again, we cut here. This minus 1 is 6. This one, again, we cut like this. Minus 47. Again, it very quickly it merges. So it becomes 1199, not divisible. And here it is divisible by 499 because 6 into 1000. 6 into 1000 minus 1. So third order oscillator is plus 6. This one, which is minus, so it is plus 6. So we do third order oscillator is 6, so group in 3. Third order, so group in 3. So again we group in 3. So this thing comes back to this, so it is divisible. This one by divisible by 7, it is actually 7 into 1000. 7 into 1000 plus 1 is 7001. So we group into 3, and third order oscillator, because 3 numbers of zeros, third order oscillator is minus 7 because it's plus, is minus 7. So we do this cut here, 3 into 3, and already cut here. Cut this one. This actually is minus 7. So again, this one becomes like this. Again, you cut. So this is minus 7 into 1, 3, 3, 4. This one, again, you cut 3 digits. This one, this thing, and this 21. This becomes 0. So this, here, if it is negative oscillator, you will come to 0 at times. So for negative oscillator, the criterion is either 0 or divisible. So we come forward. Divisibility by repeat 9 numbers. Multiplex oscillator are always 1. Like in case of 9, it became simplex oscillator, it become 9. So in case of 99, what to do? Simply, like in case of 9, we did simply add all the digits here, add in groups of 2. So this number is divisible by 99 because if you group into like this one, and so this is adding, then it should be divisible by 99. So that is divisible by 99. Because the oscillator is plus 1. So by always multiplying and multiplying by 1 and adding means multiply 1, it becomes 2, and again add. So everything is, so because procedure becomes simple, like divisibility by 9. I already since school we understood, but people left it there itself. Not didn't discuss anything about oscillator or something. Triple 9. You group in 3 and add this way, and you find that it's divisible by 999. This is 4 numbers of 999. This is divisible by 99 because you group in 4. So this, you add all these numbers and becomes divisible. There is something called hollow number. Hollow number means that both sides there will be 1, and in between there will be many numbers of zeros. It is looking like a hollow. So it is 10 to the power n plus 1 numbers. So this is divisible by 11, like it is 11. 11 we did alternative plus and minus. Here also we do alternative plus and minus, but it is actually, this is the third order oscillator. It is the third order oscillator is minus 1. 11, 1000 plus 1. So there are 3 numbers of zeros. So group in 3 numbers of zeros, you group in 3. So if we group in 3 and alternative plus and minus, then you find that this number is 229, not divisible by 1001. But whereas this number, when you group towards group into alternative numbers, it becomes 0. So this is number. So another big example is there, whether this big number, very big number, you cannot test in through calculator or Excel sheet or anything anywhere, but with little consideration that it is actually 10 to the power 4 plus 1. So my fourth order oscillator is minus 1, and you group into 4. and alternative plus and minus. It means always you add all the plus and add all the minus, and then you subtract. Subtract, then it becomes 0. Then hollow number is a special case where nth order multiplex oscillator has -1. Thus, the process leads to alternative sign addition and subtraction of digits grouped in n, like what you did in case of 11. Here, repeat 9 numbers are special case where nth order multiplex oscillator is 1, which leads to simple addition in groups of n digits, like what we did in case of 9. We, in the childhood or in later also, we never talked about divisibility in any other consideration, only left what we learned in childhood, and that is very simpler ones and very trivial ones. Now, divisibility, multiple oscillator, others. By factorizing this one, we arrive further divisibilities. For example, 857. Suppose divisible by 857. It is 7 into 857 is 5999. So third order oscillator is 6. So therefore, you have to do accordingly. So I left it there. So you know what to do. How to group in 3. And then third order group in 3 means 5 into 10 to the power 3. 6 into 10 to the power 3 minus 1. So, and do it by 6. So similarly, you have to identify. Actually, there are many other numbers which can be factorized. This actually, or divisibility by 229 or divisibility by 131, it will coming to fourth order oscillator is 3. Okay. Now this is, I exceeded 8 minutes. Thank you. My telephone number is this. You test the divisibility whether this my telephone number is divisible by 7, 13, 17, 21, 29, 31, etc. That is my exercise. Okay. Thank you. Any question?
Hope this today's PPT, everything is there in your document that you have given, because people are asking for this Excel sheet that you have prepared. So I think it is part of the PPT.
It is separate from the PPT. People wanted that. People want that Excel sheet.
Yeah. I mean, we can post it in the WhatsApp group.
Okay, I'll post it.
Yeah.
There are some other research material also, like hexadecimal numbers.
Right.
Like whatever he did, actually, not only decimal, it works with hexadecimal numbers as well. I have seen. I'll show you. This one. Applicability of basic mathematics for hexadecimal numbers. In the PPT last one, so it is actually 60. Whatever 10 to the power, 16 to the power something also will work. I've shown that this multiplication near a hexadecimal base. So these numbers are near about these numbers, near about hexadecimal base. So this can be the similar way it can be worked with. So those of you who are interested in hexadecimal can work with this one. Similarly, this recurring decimal for hexadecimal all work nicely, positive, negative, both. I have that in that Excel sheet I have. Thank you. Any questions?
Babu garu.
Okay, ధన్యవాదములండి.
Sir, could you please share the PPT also?
This PPT I have already shared.
See, try to see the group messages and then ask for the PPT. You are not seeing the group messages.
Thank you, sir. Okay, sir.
Yeah. Babu garu.
Okay. If there are no questions, we will go for Pradhana. Arun Kumar ji.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीमहीषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यम् लोकाः समस्ताः सुखिनो भवन्तु, काले वर्षतु पर्जन्यः, पृथिवी सस्यशालिनी, देशोऽयं क्षोभरहितो, ब्राह्मणाः सन्तु निर्भयाः, अपुत्राः पुत्रिणः सन्तु, पुत्रिणः सन्तु पौत्रिणः, अधनाः सधनाः सन्तु, जीवन्तु शरदां शतम्। सत्यं वद, धर्मं चर, स्वाध्यायान्मा प्रमदः, मातृदेवो भव, पितृदेवो भव, आचार्य देवो भव, अतिथि देवो भव। सर्वे भवन्तु सुखिनः, सर्वे सन्तु निरामयाः, सर्वे भद्राणि पश्यन्तु, मा कश्चित् दुःखभाग् भवेत्। ओम शांति शांति शांतिः। ओम पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते, पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ओम शांति शांति शांतिः। सर्वे जनाः सुखिनो भवन्तु, स्वस्ति।
ధన్యవాదములండి అరుణ్ కుమార్ గారు.
Thank you, sir.
Now let us recite Janaganamana. All of you please stand up and sing along with Challa Chittibabu garu. Challa Chittibabu garu.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा, तव शुभ नामे जागे, तव शुभ आशीष मांगे, गाहे तव जय गाथा। जनगण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे जय 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 हे जय हे।
ధన్యవాదములండి చల్లా చిట్టిబాబు గారు.